Okay, so this is the comparing functions lesson. It's just a couple of examples and then some practice that you'll do on your own or with a partner or group. The thing you need to be really aware of here is that the better you know the parent functions, the easier comparing functions are going to be. You really have to know the parent functions well. So if you haven't mastered your parent functions and transformations yet, I really suggest that you do the extra practice there or extra practice on inverses. If you feel like those are places of weakness, don't tackle this until you have those mastered. Okay, we're going to start just graphing x squared and x cubed because we're going to compare them. So x squared, 0, 0, 1, 1, 2, 4, 3, 9, and over here as well. And x cubed. 0, 0, 1, 1, 2, 8. So now is a good time. This lesson really will reinforce your parent functions knowledge. But if you haven't mastered transformations and parent functions and inverses yet, go back and do those first. Okay. Now we're going to compare, and we're going to do some justifications of this first problem that we're not going to do with our others, because we're going to step through it a little bit slowly. So f of 0 and g of 0. At 0, what are these functions doing? Well, for x squared, that's our f of x. X squared at 0, our y value is 0. So really, remember, this notation is asking for the y value. X is 0. What is y? Now we're going to go over here to x cubed. At 0, x cubed is also the y value is 0. So f of 0 and g of 0 are equal. So the work here looks like almost nothing, because you're just doing that symbol in the middle. But it takes a little bit to get there. Okay, f1. So at 1, f of x is 1. At 1, the y value is 1. At x equals 1, there's your y. Y equals 1. So g of 1 is also 1. So f of 1 and g of 1 are equal. Now at 2, things start happening here. So at 2, for f of x, our output is 4. So f of 2 is 4. G of 2 is 8. So our g of 2 is greater. 8 is greater than 4, so g of 2 is greater than 4. All right, negative 2. F of negative 2 is 4. G of negative 2 is negative 8. So when we're on in quadrant 2, f of x is bigger than g of x for all values. So when x is negative, let's jump over to f, part f here. When x is negative, f of x is going to be greater than g of x because f of x is above the x-axis and g of x is below. Out at positive 100, going back to E, out at positive 100, f of x and g of x are both going to be positive, and they're both going to be huge numbers. But you have to think about which one is growing faster. Our f function is x squared, and our g function is x cubed. So what we're talking about here with this 100 is 100 squared and comparing that with 100 cubed. And 100 cubed is absolutely going to be bigger than 100 squared. So which of these functions is greater as x approaches positive infinity? So that's out kind of past 100. So as x approaches positive infinity, f of x is, or I'm sorry, g of x is greater than f of x. X cubed grows faster than x squared. Which is greater as x approaches negative infinity? As x approaches negative infinity, x squared is positive, and x cubed is not. So f of x is greater than g of x. So x squared is always positive. We're going to do a little more work here with these two functions before we move on. State the interval over which f of x is increasing. So increasing, you're just looking for that uphill, and f of x is your parabola. So it's increasing from 0 to infinity. We write that in interval notation and we use parentheses because at 0, 0 is a turning point, so it's not increasing or that's not a place that you're increasing, but just to the right you are. State the interval over which g of x is increasing. Well, g of x is our cubic, and our cubic, as long as it's a positive cubic, is always increasing. So it's increasing from negative infinity to infinity. State the interval over which f of x is decreasing. So if we go back to what I drew here, f of x is decreasing until we get to 0. So from negative infinity to 0. And again, 0 is that turning point. So when you're talking about increasing and decreasing intervals, you're not going to include that turning point. Which function has a minimum value? X squared has a minimum. And our last question about these actually is talking about a different function. So now we're going to switch and talk about negative f of x. So negative f of x is going to be x squared flipped over your x-axis. Super rough sketch there. Compare the functions as x approaches infinity and as x approaches negative infinity. Okay, so I'm going to sketch both of these side by side so they're a little easier to talk about. The general shapes are really the things that you have to keep in your brain like forever and ever. So as x approaches infinity, let's see what's going on. Negative f of x is going down forever. X cubed is going up forever. So g of x is going to be greater than negative f of x. X approaches negative infinity. So here, x cubed is going down forever, and x squared is going down forever. So we have to think here which is growing faster. Like if we put them on top of each other, which one of these graphs is going to be above the other? So remember, x cubed grows faster and decreases faster than x squared. So if we put this over here, if we put x cubed over here, it would look something like that. And so x squared would be above it. So negative f of x is going to be greater than g of x. It just doesn't dive as fast. All right, we're going to do 2 more function comparisons on this video. The next functions we're going to compare, and they're going to go a little quicker, are 1 over x and 1 over x squared. So 1 over x has a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. It has a point 1, 1 and negative 1, negative 1. We like those 3 in there for each of our curves. So there's x squared. Or I'm sorry, 1 over x. Still have x squared on the grade. And then 1 over x squared, same asymptotes. But remember, when we square x, our outputs are going to be positive. The other thing that happens with 1 over x squared is that it goes to 0 faster than 1 over x. Because that number in your denominator is going to be squared, right? It's a bigger number in your denominator, which means it's going to go to 0 faster. Okay, so at 1, that's the first place we're looking at. F of 1 is 1. G of 1 is 1. So we're equal there. At 2, if it's helpful, put the numbers in. At 2, for 1 over x, we're 1 over 2. And for 1 over x squared, we're 1 over 4. So already at 2, and I didn't draw it terribly well to represent the function, but at 2, we're at 1/4. So already at 2, f of x is bigger than g of x. And that's going to continue. Let's just keep talking about the positives there. As we go out to 100, this f of x would be 1 over 100, and g of x would be 1 over 100 squared. So f of x would be bigger. Now, when we switch over and talk about the negatives, you might want to say, hey, it's going to be the same. But for 1 over x squared, it stays on top of the x-axis, and 1 over x is below. So at f of -2, f of -2 gives you a negative output, and g of -2 over here on 1 over x squared, it's going to be positive. Same thing at 100. F of -100, that's going to be 1 over -100. G of -100, it's going to be a smaller fraction, but it's going to be positive. So g of x is going to be bigger. So just talking about the general shapes of functions and the signs that go with the functions, this is the kind of work that you're going to be doing a lot in calculus, and that's why these parent functions are so important. So as x approaches positive infinity, we said f of x is going to be greater than g of x. And that's because g of x, again, those fractions are getting smaller faster. As x approaches negative infinity, g of x is going to be greater than f of x, because there g of x is positive and f of x is negative. Please, if you have any questions about this, if you're tackling these and you have any questions, please let me know. One more. So here we're comparing x squared and ln of x. X squared we've done already on these notes, so it should be a quick graph. Ln of x, remember, ln has this vertical asymptote at x equals 0. And the key points, 1, 0, between 2 and 3, 1, and between 7 and 8, 2. is 1, and at 1, ln of x is 0. So f of x is going to be greater than g of x there. At 2, again, I really think it's easier to just put in these output values. At 2, we have 4, and at 2, we're between 0 and 1. So that guy is going to be bigger again. And out of 100, positive 100, absolutely, x squared is growing faster than ln of x. So as x approaches infinity,